All right, today we're going to be asking ourselves questions about data, and we're going to be answering those questions using estimations, and eventually we'll be looking at how to exactly answer those questions. But today, let's kick it off with the empirical rule and some examples. Let's go down to page 8. So sometimes it's helpful to ask questions about data and to be able to answer them. And we're going to be able to estimate them using a nice little rule called the empirical rule. So really quickly down here, I just want to throw an example here. If I was to draw us a normal distribution looking like this, and I said, all right, how much data is on over here, most of you guys could probably look at that and say, all right, that appears to be about 50% of the area, and so that means that's about 50% of the data. Okay, right? We already talked about the percent, the area that a curve is shaded is equivalent or proportional to the percent of the data that is there, right? Because there's lots of infinite little data dots. So the empirical rule breaks this up into some nice feelings that allows us to quickly get a judgment for how much data that we're talking about. So the empirical rule is also named the 99.7, 95, and 68 rule. Just kind of why these numbers are kind of important, and we'll kind of talk about those. So what this is saying, and it only works for normal curves, but we could say that there is 68% of the area is between 1 and 2 standard deviations. Actually, I don't want to say that, not 1 and 2, but -1 and 1 standard deviations from the mean. So that would mean if you were to look at this curve and you were going to go, like, we know that the mean is in the middle, right? So there would be the mean. If we were to take the mean and add 1 standard deviation onto it, or take the mean and subtract 1 standard deviation from it, we could say that this space in here would take up approximately, again, this approximation is not perfect, but this area would be about 68% of the data, which is kind of nice to get a feeling for. So more than half of the data is in that zone. We could also say, with that being said, we know that the total area of the whole entire curve is 1. So if you did 1 minus 0.68, well, that would leave you with, 1 minus 0.68 would be about 0.32. And we have two sides. We have this side and that side. So we could take that number and divide it by 2, right? So that divided by 2 would be 0.16 on both sides, right? So we could say the area out here is approximately 0.16, and the area over here is also 0.16. So about 16% of the data is over here, and about 16% of the data is over there. So it kind of gets us a good feel for things. Another thing that's kind of helpful to know at times is we could say about 95% of the data is between -1 and 2 standard deviations from the mean. So if we were to, again, kind of relook at that, we could say, all right, the mean is in the middle of the curve. And if I went, okay, so here's taking the mean and adding 1 standard deviation. But then if you took the mean again, but this time you went 2 standard deviations away, you'd end up over here, right? 1 standard deviation, 2 standard deviations. And if you did the same thing in the other direction, so take the mean, but this time subtract off a standard deviation, and then take the mean and subtract off another standard deviation, well, again, that would also be 2, oh my gosh, would also be 2 standard deviations away. Dink, dink. And we would say over here that this zone, or all of this data, it is about 95% of the data. Right? And so, yeah. And besides that gets you a feel for here. We can also think about how much data is out here on these two sides. Right? So think about 1 minus 0.95. Well, that would get you with this. And then if we took that and divided it into this and this, 0.05 divided by 2 would come out to be about, if I could get this pen to work, 0.025% of the data over here and 0.025 of the area over there, which if you turn that to percents, it's about 2.5% of the data over here and 2.5% of the data over here. Again, just kind of giving you a good gut feeling for how much data is where. And then last but not least, if you are working with that middle chunk of data, sorry, struggle is real right now, where you are 3 standard deviations away, well, that's practically everything. From -3 to 3 standard deviations away is about 99.7% of the data. It's practically it all. I'm not going to get too fancy with it, but here is your mean. If you took the mean and added, I don't really feel like putting this on, but maybe I should. Here is 1 standard deviation. Here is 2 standard deviations. And then if you added another one, you'd be 3 standard deviations away. Isn't this exhilarating? I'm having the time of my life. Okay, minus a standard deviation, take the mean minus 2 standard deviations. Having the time. Okay, I just am getting OCD with these stupid colors. They're not even good looking, but hopefully you can kind of see what I'm talking about. Okay, but this time, and hopefully you can see, there's 1, a 2, and a 3, and it goes in both directions, right? So this time, I would say this chunk of the data from -3 standard deviations all the way up to the 3rd standard deviation, well, that consists of a solid 0.997% of the area of the curve, or 99.7% of the data. And then thinking about that, we might be like, okay, well, how much data is on the outside part? So we know the total area is 1 minus 99.7. 1 minus 0.997 comes out to be 0.003. That's what's remaining out here and here. So if we divided that by 2, that's going to get us a very, very little number. So the area that's out here of data is 0.015. If you were to change that to a percent, that's not even 1% of the data, right? So that's over there, and that's over here, right? So again, it gets us a gut feeling for how much data, the majority of the data, is between -3 and 3 standard deviations away. Let's go back up to here and do a little recap, shall we? It says, for approximately normal distributions of data, right? Because this is our reality, is that not everything is really going to be perfect all the time. Like up here, a lot of times it's going to be approximations. So we could say about 68% of the data will be between -1 and 1. About 95% of the data will be between -2 and 2 standard deviations away, and about 99.7, practically everything, percent of the data will be between -3 and 3 standard deviations above the mean. So looking pretty glorious. This is the empirical rule. The reason that this is really helpful is it's helpful to make estimations of just answering quick questions about data. We're going to practice that here in 1 second, looking at these distribution of male heights.